This video is for Section 3.1, Scatter plots and correlation. So we're going to begin by talking about two definitions that you may remember from the beginning of the class. That's response variable, which is a variable which measures the outcome of a study, and explanatory variable, which is a variable which may help influence or explain changes in a response variable. So to begin, we're going to look at an example. So Julie asked, can I predict a state's mean SAT math score if I know its mean SAT critical reading score? Jim wants to know how the mean SAT math and critical reading scores this year in the 50 states are related to each other. So the question is, for each student, identify the explanatory variable and the response variable if possible. So Julie is wanting to ask if she can predict the state's mean SAT math score if she knows the SAT critical reading score. So the explanatory variable in her situation would be the mean SAT critical reading score. And the response variable would be the mean SAT math score. So what she's saying is, if she has the mean SAT critical reading score, that she should be able to predict the mean SAT math score, which would mean that the critical reading score had some sort of effect on the math score. Jim, however, just wants to know if the mean SAT math and the critical reading scores are related to each other. So actually, he has no explanatory or response variable. He's just comparing the information. For the check your understanding, it says for number 1, how does drinking beer affect the level of alcohol in our blood? The legal limit for driving in all states is 0.08%. In a study, adult volunteers drank different numbers of cans of beer. 30 minutes later, a police officer measured their blood alcohol levels. So we want to identify the explanatory and the response variables in this particular situation. So for number 1, the explanatory variable would be the number of cans of beer. And the response variable would be the blood alcohol level. Number 2, the National Student Loan Survey provides data on the amount of debt for recent college graduates, their current income, and how stressed they feel about college debt. A sociologist looks at the data with the goal of using amount of debt and income to explain the stress caused by college debt. So for this question, there's actually 2 explanatory variables. So that would be the amount of debt and the income. The response variable would be what's caused from the amount of debt and income, which would be stress. Displaying relationships. So when we're displaying relationships, one way we may do that is with a scatter plot. So a scatter plot shows the relationship between two quantitative variables measured on the same individuals. The values of one variable appear on the horizontal axis, and the values of the other variable appear on the vertical axis. Each individual in the data appears as a point in the graph. So how to make a scatter plot. First, you're going to decide which variable should go on each axis. 2, you're going to label and scale your axes. And 3, plot individual data points. If applicable, always plot the explanatory variable as the horizontal axis, so that would be like your x-axis. So for our first example on making a scatter plot, 9th grade students of the Webb schools go on a backpacking trip each fall. Students are divided into hiking groups of size 8 by selecting names from a hat. Before leaving, students and their backpacks are weighed. Here are the data from one hiking group in a recent year. So you've got your body weight and you've got your backpack weight, and both of those are in pounds. So we have the question it's asking us to do is to make a scatter plot of the relationship between body weight and backpack weight. So we should follow the steps that we talked about earlier. So the first one is to decide which variable should go on each axis. So the weight of the student can carry depends on his body weight. So we'll use body weight as the explanatory variable. Which we should always try to use as the x-axis. And then we will use backpack weight as the response variable, which is our y-axis. So now we're going to label and scale our axes. So I've already labeled. It's probably also good to say that this is in pounds and this is also in pounds. And so to scale our x-axis, we should look at the body weights and see kind of what they look like. So the body weights range from 103 to 187. So we may decide to start scaling at 100 pounds and then make each tick mark be 10 extra pounds. So if we do that, we would do 100 and then 110, 120, 130, 140, 150, 160, 170, and 180. So then we should look at the backpack weight here and see what we want to scale our y-axis to be. So the backpack weights vary from 24 to 35 pounds. So we may decide to scale our y-axis starting at 20 and then do tick marks that are 2 pounds each. So we would have 20, 22, 24, 26, 28, 30, 32, 34, 36. So our third step is to plot individual data points, and so that would come from the information up here in the table. So a backpack or a body weight of 120 pounds can carry a backpack weight of 26 pounds. So I would go to 120, then go to 26 and put a point. It's actually off a little bit. 187 was 30 pounds. Really, I should probably put 190 on there as well. So 187 would be maybe somewhere in here, and they were able to carry 30 pounds. 109, 26. 103, 24. 131, 29. 165, 35. 158, 31, and 116, 28. Interpreting scatter plots. So how to examine a scatter plot. As in any graph of data, look at the overall pattern and for striking departures from the pattern. You can describe the overall pattern of a scatter plot by the direction, the form, and the strength of the relationship. An important kind of departure is an outlier, an individual value that falls outside the overall pattern of the relationship. So interpreting a scatter plot, an example would be like if we went back to the scatter plot that we just created for backpack weights and body weights of a group of hikers. So this is an example of kind of what ours looked like. It may be a little bit different than mine just because it's kind of a little bit more spread out, but it is pretty much the same graph. So the problem is describe what the scatter plot reveals about the relationship between body weight and backpack weight. So first we're going to describe the general pattern, and then we'll identify any deviations from the pattern. So let's talk about the direction. In general, it appears that lighter students carry lighter backpacks and heavier students are carrying heavier backpacks. We say that there's a positive association between these variables. So it appears that as your body weight increases, your backpack increases. All right, so the next thing we'll talk about is the form. So there seems to be a somewhat linear pattern in the graph. And so basically that just means that the overall pattern follows a straight line. So if we're looking at this, basically, could we draw a line, a straight line that would go kind of up and at an angle? And would the points kind of fall pretty close to that line? And then we'll talk about the strength. So since the points vary somewhat from the linear pattern, the relationship is only moderately strong. So basically, again, if I were to draw in a straight line, how close are those points to the line? So we've got some of them that are a little further away. This one is definitely far away. So for the strength, we would say that it's moderately strong. To be like extremely strong, they would all basically be in a perfect line. We do see one possible outlier in the graph, and so that would be this one right here. And so that is a hiker with a body weight of 187 pounds and a pack weight of 30 pounds. He seems to be carrying less relative to his weight than the other group members. All right, so let's talk about positive association and negative association. So positive association is when two variables have a positive association when they go above average values of one tend to accompany above average values of the other, and when below average values also tend to occur together. So basically when one goes up, the other goes up, or when one goes down, the other goes down. Negative association is when above average values of one tend to accompany below average values of the other. So one is up, one is down. So the Storms family arrived at Old Faithful after it had erupted. They wondered how long it would be until the next eruption. Here's a scatter plot that plots the individual or the interval between consecutive eruptions of Old Faithful against the duration of the previous eruption for the month prior to their visit. So one says to describe the direction of the association or the relationship. Explain why this makes sense. So for number one, we would say that there is a positive association because as we look at that, it appears that the longer the duration is, the longer the interval is. All right, 2 says, what form does the relationship take? Why are there 2 clusters of points? The form is roughly linear with 2 clusters. The clusters indicate that in general there are 2 types of eruptions, one shorter and one somewhat longer. So again, if we thought about this, we could draw in a line and we would see that all these points are kind of in this line. We also see that there's a group here and there's a group here. So to answer 2, we would say it's roughly linear. And then we would say 2 clusters represent 2 types of eruptions. Short and longer. 3. How strong is the relationship? So if we're looking at the line that we drew, we would say that the relationship is fairly strong. 2 points define a line, and in this case, we could think of each cluster as a point. So the 2 clusters seem to define a line. Four asks if there are any outliers. So if we look at our scatter plot, we can see that there are a few outliers around the clusters, but not many, and not very distant from the main grouping of points. So we can see that like this, we might consider an outlier. We might consider this one an outlier or this one, but they're still fairly close to where our main clusters are here and here. And 5 says, what information does the Starnes family need to predict when the next eruption will occur? So basically, the Starnes family would need to know how long the next eruption lasted in order to predict how long until the next one. All right, so 10 on this particular page, we're going to go back to the body weight and the backpack weight, and we're going to do it on the calculator. So to do this on the calculator, you are going to go into lists. And you're going to put all of your information in L1 or L2. So let's let L1 be body weight. And we'll let L2 be backpack weight. And so we need to make sure that whatever the body weight was matches up with the backpack weight that goes with it. All right, so once we do that, you're going to do second y equals, because that will do stat plot. You want to hover over stat plot 1, hit enter, and make sure that it's turned on. And then when we're looking at type, you want to go with this one, so the one that looks like a scatter plot. So then basically it's asking, was your x-axis L1? It was. Was your y-axis L2? It was. And then you can change whichever mark you like. So I'm good with this one, but you can change it to whatever you want to do. And then blue will just, you won't have this, but that just means the color that it's going to show up. So then you would go to graph. And once you do that, then you're going to need to go to zoom and then stats, and that will show your information. The reason that you had to do zoom and then stat is because if you remember when we did our scatter plot, our axis started at 100. Your calculator is automatically set up to do a window of like 10. So when you do zoom stat, it's going to take you to where that information is. All right, so measuring linear association. So correlation measures the direction and the strength of a linear relationship between two quantitative variables. So how to calculate the correlation R? So suppose we have data on variables x and y for n individuals. The values of the first individual are x1 and y1, and the values for the second individual are x2, y2, and so on. This means that the mean and the standard deviation of the two variables are x bar and s sub x for x values, and y bar and s sub y for the y values. The correlation R between x and y is this. Or more compactly, 1 over n minus 1, the summation of your x times your y. So all your x information times your y information. So on this problem, our earlier scatter plot of the body weight and backpack data for 8 hikers is repeated in the margin. So this is our information here. For these data, R is equal to 0.795. So we want to interpret the value of R in context. So basically, we can look at 0.795. I guess this is A. And we would say that this confirms what we see in the scatter plot. Because this number is relatively high, we would say that there is moderately strong, positive, because it is a positive number, linear relationship, between body weight and pack weight. B says, what effect would removing the hiker with the heaviest body weight from the data have on the correlation? Justify your answer. So basically get rid of that outlier that we said that we had. So all that would do is increase the correlation. Since the remaining 7 points are more tightly clustered in a linear pattern.